You can see on the board behind me, we have a periodic table. Yes, it is a periodic table. No, it's not. It doesn't have any elements on it. It's a periodic table. Okay, I'm using my Jedi mind powers on you. It is. Okay, so the outline of my periodic table, I'm going to write on it, so we need an outline of the periodic table. Let's go over the periodic table basics, the organization, how things are set up. I'm not going to go into too much into why they're set up the way they are. That's more periodic table history, and we'll eventually get to that. But let's go over that periodic table first. We're going to wrap up some things for this week. What are ions? What are diatomic molecules? And things like that that are still on the list. Because some of you are checking this stuff off going, he didn't cover that. He needs to cover that. Okay, I'm going to do it now. Okay, here we go. The periodic table is, what we need to know now is how it's organized into some groups. Groups or families. Groups or families are vertical. Periods, hence periodic table, are sideways, this way. Okay. So you can see that on any periodic table, and here's one. I've enclosed that one for you, copy of that one, copy of this one, different ones, but they all have this section pulled out. These are the rare earth elements. They call them rare because they're rare. They're found in the earth, rare earth. So you get it? Rare earth. And these are pulled out because if we don't pull them out and down, you have a very wide periodic table. I mean, use your imagination. And this is also, I'd be way over here, trying to do this, and it just makes it so long. So for convenience sake, they pull that out and down. But it does actually tuck up in this part of the periodic table. Okay, now, two groups over on the left we should know. This group here, this first group that starts with hydrogen, it's called the alkali. Alkali. Alkali means basic, by the way. Alkali soap is alkali. It means basic. So, I mean, as basic is not as fundamental. I mean basic as in base versus acid. So this is alkali. These are alkali metals. Right? All this stuff in here, sodium, potassium, lithium, alkali metals. Second group, we have the alkaline. Alkaline. For any of you old timers out there, you will remember a baseball player by the name of Alkaline. Alkaline. Some of you might know what I mean, but probably not. Okay, alkaline earth. Alkaline earth metals. I got calcium and magnesium called earth metals. Those are calcium and magnesium are huge in making up the crust, fundamental part of the earth. Geography, not geography, what's the other course? Geology. All right, one is maps, one is rocks, okay? You rock people, you would know that. Calcium and magnesium, part of the earth crust. Okay, then in the center, here, we have what are called the transition elements. Actually, the rare earth are part of the transition elements. There's a lot of transition elements. So the biggest clump of elements, transitional metals. And they are all metals. And we'll go over what is a metal, what is a non-metal, and why in a second. So, okay, then over here, we've got some boron, some carbon, oxygen, and then we get to fluorine. In this fluorine group, here's fluorine. This group here is called the halogens. You've heard of halogen headlights before. You know, they have these elements of halogens, a halogen group. This group right here. Then, you know this one, I think. Noble or inert. Noble or inert gases. Noble or inert gases. Actually, these weren't discovered. The helium, the neon, the argon, those gases there, xenon, those weren't discovered until late in the game. We're talking late 1800s, early 1900s. It's relatively late for discovering elements. And why is that? Because they're inert. Well, what does that mean? That means they don't do anything. They sit there. Inert means couch potato. Thank you. Thank you very much. That was my couch potato imitation. Acting, I should get an Academy Award for that. Okay, inert means you don't do anything. These don't react with anything. If they don't react with anything, it's going to be pretty hard to find them. All right, now, when they were discovered, the first couple of them were discovered by British chemists, and these British chemists thought it was funny, this is true, I'm not making this up, they thought it was funny that let's not call them inert, let's call them noble gases because they don't do anything like the nobility of England. Sit around on your butt all day and wave, hello, okay? I'm like, yeah, that's why they named them noble gases. Okay, so there are some basic groups we should know. And we should also know this, that if you look on a periodic table, this one has a bold step-like line going down on it. This one also has a bold step-like line going down on it. That bold step-like line divides the metals versus non-metals. Your metals are over here. Your non-metals are over here. That's important to know because you're going to name compounds, and when you name compounds, you got to know metals and non-metals because they have different naming systems to them. So the metals versus non-metals, you have to name them differently because they are metals or non-metals. So if you have a compound with two non-metals in it, you're going to name it differently than a compound with a metal and a non-metal. All right? Check out that video. All right, now, along this step-like line, some of these are silicons here, germanium. You have what are called the borderline ones, the metalloids. Metalloids, so they're kind of metal-ish, but they're not metals. They're metalloids. Well, why? Because they're on the border, so they have characteristics of metals and non-metals. Silicon being a very important one. Metals, one characteristic of any metal is it's conductive. They are good conductors. No, not that kind of a conductor. We're talking electrical conductors. And if you're an electrical conductor, you allow electricity to go through you. Well, silicon is a metalloid. Now it has some metallic characteristics. It does allow electricity to go through it, but not as quickly, all right, that's amperage, not as quickly as other metals. There's a huge advantage to that. Silicon Valley, California. Why do they call it Silicon Valley, California? Because a lot of semiconductors, okay, meaning they allow electricity through them, but not too quickly, were developed in Silicon Valley. So semiconductors, things like computers and your cell phone, the things that everybody's addicted to now, that I'm recording this on, they need these semiconductors. This is just a little fun fact for you. This is fun. You'll learn all kinds of things in this class. And the reason this is kind of cool is because you can't have electricity go fast through delicate little wires. What will happen to that little wire? Delicate little wire, so delicate and cute. Right? You can't have that. You need electricity to go through these wires, but not quickly, so use a semiconductor. See, you're learning stuff here. Okay, so metals also, another characteristic of metals is they want to give away their electrons. So these things, metals want to give away their electrons, and metals are always on the left of any chemical compound. So if I have salt, NaCl with table salt. There's a lot of different kinds of salt, but this is common salt, table salt. Sodium is a metal, chlorine is a non-metal, metal always on the left. You know that, though. I'm just pointing it out and reminding you, that's all. Okay, so there are some characteristics, some things we need to know about the periodic table that come into handy, especially right after this video. You're going to start learning about naming compounds, and you got to know who the metals and non-metals are. Okay, what else? What else do we need to do here? Let's see. Diatomic molecules. So, I just erased everything, and I just thought, you know what? I'm going to get rid of this mess. Messy, so messy. Wow, I didn't know I could play soccer. It's messy. I didn't know it could play messy. Lionel. All right. It's funny. Going back to my outline of my periodic table, we have molecules and ionic compounds. What's the difference? An ionic compound, actually I just put an ionic compound on the board just a minute ago. I put NaCl. That's an ionic compound. Why? Because you have a metal and a non-metal. If you have a metal and a non-metal, you have an ionic compound. And we'll get into this when we get into bonding, but metals are going to be positively charged, the non-metals negatively charged. It's a natural fact, opposites attract. Ionic compound. A molecule is a compound that has nonmetals. You know some, we've gone over them already. CO2, carbon dioxide, those are two nonmetals. Remember our periodic table line. Non-metal, non-metal, carbon and oxygen. Molecule. Okay, so the type of compound name, ionic compound or molecular compound, tells you not only what kind of bond you have, ionic versus molecular, but also what's involved. Metal, non-metal, two nonmetals. All right. But there are some molecules that are really important. They're all important. Everybody's important. Come on. But there are 7 of them, molecules that are called diatomic. These diatomic molecules you just have to know. If you don't know them, they're going to mess you up for this entire course. Di, 2, atomic, atoms. Diatomic, 2 atoms. The diatomic molecules are as follows. They're actually quite easy to remember. If you look at your periodic table, okay, we're going to start with nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. They're easy to remember because there are 7 of them. Nitrogen, oxygen, fluorine, bromine, and iodine. Okay, nitrogen, oxygen, NOF, fluorine, chlorine, bromine, and iodine. Okay, those are, now remember, there's 7 of them. So these diatomic molecules, what there are, now some of you are looking up here going, there ain't 7 there. No, there's not. There's only 1, 2, 3, 4, 5, 6. You can't count. Well, okay, there's one other one that makes up the 7th one that is over here, and that's hydrogen. 1, 2, 3, 4, 5, 6, 7. Actually, they're easy to remember because there are 7 of them. 1, 2, 3, 4, 5, 6, 7. They start with element number 7, nitrogen, element number 7, and they form the shape of the 7. Huh? Pretty cool, huh? 777. Okay, the opposite of 666. 777, awesome number. Good number. So those are diatomic. Hydrogen's the oddball. You know, just didn't want to play. Just took its ball, went home. Said, I'm out of here. These, whenever they are by themselves, by their lonesome, okay, oxygen will always be O2. Nitrogen will always be N2. Hydrogen will always be H2. Fluorine will always be F2. And chlorine and bromine and iodine are always going to be like this, diatomic, 2 atoms, when they're by themselves. Now, that doesn't mean they're going to be like that in a compound. Yeah, they are. Look at this up here. You have 2. See? O2. It's diatomic. No. Okay, carbon monoxide. We've been over this. So oxygen does not have to have 2 in a compound. It can have 1. It just so happens that my example up here, carbon dioxide, happened to have 2. That's just coincidence. Carbonate, which we all should have memorized, is a polyatomic ion, hence, polyatomic meaning many atoms, polyatomic ion, and that has 3 oxygens in it. So when oxygen's in a compound, it can have 1, 2, 3, 4, I mean, any number of them, but when it's by itself, always will be diatomic, and you need to know that. These are going to mess you up, like Mr. T, will mess you up. All right, Rocky 3, remember? Rocky 3, yeah. You ain't so bad, you ain't so bad, you got nothing. That was Rocky to Mr. T, by the way. Some of you know what I'm talking about. If you haven't watched that movie, go watch it now. I'll wait. Okay, you back? Was it good? Yeah, it was good. Okay. So we have our diatomics. You've got to know them, those 7. Polyatomic ions. Okay, I put a whole list of them together for you. And actually, I'm going to put it in order after this video, so you'll see the polyatomics that you need to know. And let's see what else. Oh, we got one more thing here, I think, on this list I need to go over. Formulas, chemical formulas. Okay, chemical formulas. You will see chemical formulas sometimes. Okay, here's one. You remember this one. Who can get it first? Who can get it first? Who? Come on, hands. Anybody? Winston. That's glucose. Winston, very well done. That is glucose. Or dextrose, actually. It's a Dextrose and glucose are sugars. Biology. Okay. They're isomers of one another. Yeah, that's glucose. Okay, pretty important if you're a biologist. Now, this is what's called the molecular formula for glucose. Molecular formula means actual retail price without going, oh, no, its price is right. It means the actual formula, okay? So that is the molecular formula for glucose. The empirical formula for glucose ain't that. Empirical formula, what's that? That's the simplified ratio showing formula. An empirical formula shows the ratio of the elements in the compound in reduced form. So the ratio here is 6, 12, 6. That's a 1-to-1 ratio. For every 2 hydrogens, there is 1 carbon and 1 oxygen. That's the empirical formula. It shows the reduced ratio. It's a ratio showing formula for the compound. And this becomes important. Thinking. Yeah, the next time that we meet, my next set of videos, we'll have how to solve problems using an empirical formula and a molecular formula. So we're going to need to know what those are. It's important to know the difference between the two. One more example here. What would the what are the empirical and molecular formulas for methane? Billy. Billy's always the angsty one, but he's in a good mood today. Okay, so it's good. Billy. The empirical formula is the same as the molecular formula. What do you mean, Billy? Well, it's already in its reduced form. You can't reduce 1 down farther than 1, so therefore, it's already reduced. It's a 1-to-4 ratio. So the actual formula, molecular formula for the methane is CH4. The empirical formula, the reduced formula, was also CH4. Wow, Billy, that's really good. And you said that with no angst today? I mean, really impressed. You've come a long way, Billy. Thank you. That's awesome. That's great. Billy did a good job. Now, if we have something like C2H4, okay, it's ethene, a little organic chemistry there, but it's ethene. Ethene, C2H4, is the actual formula for ethene, but the reduced empirical formula is CH2. Okay. So you got to know that difference. That becomes important when we solve some problems. We have a lab on empirical molecular formulas, and we also have some problem solving to do with them, so we do have to know them. They do get incorporated. All right, I think that's going to wrap up this video. Oh man, this is 18 minutes. Well, let me get out of here.